So in this video, I'm gonna discuss to you the IP addressing. And first, we will identify what is IP addressing. So an IP address is an address used in order to uniquely identify device on an IP network. The address is made up of 33 binary bits, which can be divisible into a network portions and host portions with the help of subnet masks. The 32 binary bits are broken into 4 octets. So 1 octet is equals to 8 bits. Each octet is converted to decimal and separated by a period dot. So for this reason, an IP address is said to be expressed dotted decimal format. For example, is 172.168 uh, 116.81.100. The value each range from 0 to 255 decimal or 0, 0, 0, 0, 0 and 0 is in 1, 1, 1, 1, 1, 1 and so on in binary. Here is show how binary octets convert to decimal site. Most bit or least significant bits of an octet holds a value 20 of 20. The bits has the left that holds a value of 21. This continue until the left bits of most significant bits which holds a value of 27. So it's for binary are one decimal value equivalent would be 255. So we will do a example here. So we will put a 1, 1, 3, 4, 5, 6, 7 and 8. So each number of 1 they have a value. Now this first 1 to 8 in the first line, so they have a value of 1 to 8, and then as you to be see clearly. So the first number is a value of 1 to 8, and the second have a 64, and then the third one have 32 value, and the fourth one have a 16 value, and 8 and 4 and 2, and the last one have 1. So this is the value of binary. So it will be equivalent to 255 if we compute 128 plus 64. Now we will compute that 128 and plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So it will be equivalent to 255. Now here is the example of octet conversion when not all the bits are in set. All bits are set on number 1. So we will proceed to example that they have a 0. Now we'll put example of 0, 1, 0, 0, 0, 0, and 0 and 1. Now we will identify what is the value. If the value of this is 0, now will be equivalent to 0, and then the next one, we have the second one have the value of 64. We will put a 64. If we see that the bits have 1, they will have a equivalent of their destination number. So will be 0, 0, 0, and the last one we have 1 here. And now we have the answer of, if we add the 64 plus 1 is equal to 65. So in this example shown of IP address represents both binary and decimal. So next, now we will try the if this decimal we will convert it into the binary. Now if example of 10 dot 1 dot forget that 23 dot 19 so this will be our decimal that we will convert to binary. Now we will set this like this one. So first we have a 10, so it will be so this one we need for because 8 plus 2 is equivalent to 10, though we will put here a 0 0 0 0 and then 1, then 0 0 1 0, like this format. So the next part of this is 1. So we all know is this one is only have the value of 1. So all of the number 2 4 3 4 5 6 7 and 1, so this will be the value of 1. So the next we have a 23. If we look to our binary format, so we have 23, so this will be excluded. We have 0 0, and then we have a 16, and then we'll have the remaining of 16 17 18 19 20 21 22 23. So 16 equal to 0. The next one is 1 1 1, equivalent to 23, and the last one is 19. So 19, so we have a 16 17 18 so we have this 16 and this 2n plus 1, so we have 0 0 0 0 0 0 16 1, and then 0 0 and then 1 1, equivalent to 10 is equals to 1, then this one is equivalent to 23, and this one is equals to 19. This on how we'll convert the IP at the decimals, convert octets to decimals. So these octets are broken down to provide a addressing scheme that can accommodate a large and small networks. There are 5 different classes of networks of A to E. This is documents, focuses classes to A to C, classes D and E. Reserve and discussion of them beyond the scope of this document. So we have a note. Also note that terms as class A and class B and so on are used this document in order to help facilitate the understanding of IP addressing and subnetting. These terms are rarely used in industry anymore because introduction of classes interdomains routing. So in a class, A address first octets network portion. So the class A example is figure 1, has a major network addressing as 1.0.0.0 is 127.255.255.255 octets of 2 and 3, and the next 24 bits. For the network manager divided by subnets and hosts, and she or he sees fit. A class A addresses used and for networks have more than 65,536 hosts, actually up to uh, so I have a 16 million and 777 and 214. So in a class B addressing first two octets the network version, so that class B example figure 1 in the major network addresses of 128.0.0 and a subnet mask of 192.255.255.255 octets of 3 to 4 and 16 bits. Are for local subnets and hosts. Class B addresses are used for networks that have between 256 and 65,534 hosts. So in a class C addresses for 3 octets the network portion, the class example, so has a major network address of 192.0.0 and the 223.255.255.255 octets of 4 to 8 bits in a local subnets and hosts. Perfect for networks less than 254 hosts. So this is the class A, the class B, and class C. An IP address on a class A network that has not been subnetted would have an address mask pair similar to 8.20.15.1 and 255.0.0.0. In order to see how the mask help you identify the network nodes, parts that address converter addresses and mask to binary numbers. So this one is the example. So we have 8. So I have a value of 1, 2, 8, 64, 32, 16. I have the value of 1 here. So 8. And then 20, we have 16 plus 4 equals to 20. And then we have 15. So 1, 2, 4, 8, 15, and then 1. So we have, next one is 255. So 255, they have complete value of 1 because of total of this 1, 2, 8, 64, 32, 16, 8, 4, 2, 1 have the total of 255, and the rest will be 0. Now we will identify the host, the net ID and the host ID. So we identify the net ID. So net ID will be this one, 8. So of the value of 1 equals to 8, and then the host ID will be this one for the, and then 1 1. So we'll have the answer of 20.15.1 is the rest of 20.15.1 is will be the rest of 18. So will be the host ID. Now we will proceed to the sample exercises. Now that you can have understand of subnetting, put this knowledge is used in this example. You are given two addresses mask combination written with a prefix length of notation. We have been assigned two devices. Your task is to determine if the devices are same subnet, different subnets. You use an address mask each devices in order to determine to which subnet each addresses belong. So device A is 172.16.17 and 35 prefix of 20. Device B 172.16.128.15 prefix of 20. Determine the subnet for device A. So we have a 172. So we will identify that. So 172, we have first we have the 128 and then 0, 128 plus 32 and then 16 and then 32 plus 8 and then plus 4 and then the rest will be 0. This equivalent to 172, 168 plus 32 plus 16 plus 8 plus 4 equals 172. Now we'll proceed to 16. Now we'll proceed to 16. We have a 16 a value of 1 doon. So input of 1 sorry 0 0 0 1 and then the rest will be 0. 1 3 6 7 8. Now next we'll have a 17, so we have a 16 here and we will have a 1 here, so will be 0 0 0 and 1 and then 0 0 0 and then 1. Next is 30, so we have a 16, so 0 0 0 and then 1 1 1 1 and then 3 6 7 8. We have 16 plus 8 plus 4 plus 2 equals 30. Now proceed to the subnet mask. We'll identify this one. So we have a complete 255 of, so we have complete here 1 1 2 3 4 5 6 7 8 and 1 and 1 2 3 4 5 6 7 8 1 that, and we have a 240. Now we will identify that in 128 plus 32 plus 64 plus 32 plus 16, and we will the rest is 0. And then we have a 0 here, and we will put a 0. Now the subnet will be interchanged to this, like this one, 172.16.16.0. Now this will be the interchange of the subnet mask, of the subnet, sorry for that, subnet. Then we'll proceed to the next number. So we have a 172.16.128.15. So like this one, we have 172.16. So we will copy we all know the answer. Then 28, so we will identify the number of 28. We will have a 0 0 0 and then 1 and then 1 and then 1 1 and then the rest will be 0. Next one is 15, so we have a 0 0 0 0 and then the rest will be have 1. Now we identify the subnet mask. So first is have complete of 255. Next have 240 have the same, like in the number 1. Then the last is 0. And the subnet mask will be have the same subnet in this one. So from these determinations that device A and device B have addresses have the same subnet because they have the same numbers of have the same subnet mask and equivalent number, so therefore they have the same subnet. So this is all about in IP addressing, and that's all. Thank you.